circular motion of a car on a level road. So circular, whenever you are going having a journey, so we are seeing that the curved road. Okay, so this curved road is a horizontal road. There is a no upward thing. So this is a level road. This is a center of the curve, center of the curvature. So this is a curved road. This is a car. So the level of the road will be equal. It will be horizontal. Then what we are seeing that there is a two tires. The weight of the car will be acting downwards. The radius of the curvature. That means from the center of the curve to the road is radius is r. Radius of the circular motion. This circular motion, this circle radius is r. So this tire also experience a friction force towards the center of the curve, and this tire also experience a friction force towards the center of the curve. The normal forces R1 and R2 are acting upwards. Hence, these two normals are add up and give the final normal reaction force R is equal to R1 plus R2. This R is equal and opposite to weight of the car. So the force of friction between the road and tires provides a centripetal force. Whenever the body is moving in a circular motion, there will be this is a circular motion. This circular motion is towards the center of the circle. So that force is called as a centripetal force. So this centripetal force is required to keep the car in motion. Otherwise, what will happen? The centripetal, there is no centripetal force and this friction is not equal, means this car will be slip down. That is, we are going to derive the expression for that one. Okay. Again, I will repeat. The force of friction between the road and the tire provides a centripetal force. That means both the friction force F1 and F2 will move towards the center of the curve. So we can write that F1 and F2 are acting inwards, inner tire and outer tire. R1 and R2 are the normal forces. R is the radius of the circular road. V is the constant speed of the car, and mg is the weight of the car. F1 is equal to mu R1 and F2 is equal to mu R2 according to laws of friction. Mu is equal to F by R. So F1 by mu R1, F2 is equal to mu R2. The normal force balances the weight. So no, the normal force balances the weight. So R1 plus R2 is equal to mg. Finally, we come to the conclusion. The total frictional force is equal to F1 plus F2. Then mu we can take an outside R1 plus R2. What is R1 plus R2? mg. So the total frictional force is equal to mu into mg. For the car stay on the road, the maximum force of friction must be equal or greater than the centripetal force. So the centripetal force is here. This is the frictional force. If this frictional force and centripetal force must be minimum equal, and the friction force must be greater than the centripetal force, then only the car will stay on the road. Otherwise, what will happen? The car will be slip down. So mu mg which is greater than or equal to mv squared by r is a centripetal force formula. M and m get cancelled. Then v squared by rg is less than or equal to mu. So if you come this mu mg here, mu here means rg come to denominator, v squared by rg. Then I will write in this one to left side and this one to right side less than or equal to. Then v squared is equal to mu rg. For maximum speed with the car can turn safely is V max is equal to root of mu rg. So very simple, students. If you understand the diagram clearly, it is easy for us. So both the frictional force will be acting towards the center. That frictional force is called as a centripetal. That will be balanced by centripetal force. So the frictional force is mu mg. Then the centripetal force is mv squared by r. That must be greater than or equal to this frictional force. Then we are equating these things. We come to the conclusion. The car maximum velocity must be equal to root of mu rg, radius of the circular road, g is a gravity, and mu is a coefficient of friction between the road and the car tire. Similarly, we are going to see the same situation, circular motion of a car on a bunked road. What is a bunked road? A system of raising a A system of raising a outer edge of the curved road above the inner surface. So in previous case the surface is a horizontal, but here the outer edge is raised upwards with an angle theta. So that is called as a bunked road. Here the situation is very different. The center of that means the weight of the car will be acting downwards. The normal reaction will be acting in this direction. There will be a horizontal normal reaction and a vertical normal reaction. So the horizontal normal reaction is cos theta or sin theta. Then here what will happen? The friction will be acting towards the center of the circular road. That means it will be acting as a centripetal force. So this centripetal force will be, this is a frictional force, F cos theta, F sin theta. Very simple, students. If you are taking an inclined angle, the weight will be always acting towards the center. This will be mg. But R will be inclined like this in this direction. So this R is a force, normal reaction force. It can be resolved into horizontal component and vertical component. This is R cos theta or sin theta. Then again the friction is, in this case the friction is moving towards the center, that is the same thing. The friction of the tire will move towards the center of the curve. So that friction force is resolved into horizontal component and vertical component. Here the horizontal component is in this direction and here the horizontal component is in this direction, as we have to go along with the object orientation. Hence it is clearly F cos theta or sin theta is equal to centripetal force, because the force which is moving towards the center of the curved road is r sin theta and F cos theta. So r sin theta plus F cos theta is equal to mv squared by r. This is a horizontal component addition. Then what about the vertical component? That is a vertical direction. F sin theta and mg are acting in the same direction, which is equal to r cos theta. So mg plus F sin theta, which is equal to r cos theta. That is we are written in the next page. So r sin theta plus F cos theta is equal to mv squared by r. F sin theta plus mg, which is equal to r cos theta. So I will bring this mg this side. So what will happen? R cos theta. That means you bring this F sin theta this side, means r cos theta minus F sin theta is equal to mg. So equating 1 and 2, there is a 2 equations, 1 divided by 2. So we are dividing both the equations. R get cancelled. Sorry, it will not cancel. So r sin theta plus F cos theta is equal to mv squared by r cos theta minus F sin theta, which is equal to mg. Get cancelled. Dividing r cos theta in the numerator and denominator of the left side alone. So r sin theta by r cos theta plus F cos theta by r cos theta. So r cos theta is divided in numerator and denominator of left side alone. Again the r cos theta by r cos theta minus F sin theta by r cos theta, which is equal to v squared by rg. So r get cancelled. Sin theta by cos theta is a tan theta. So cos theta get cancelled. F by r is mu, coefficient of friction. F is equal to mu r according to law of friction. So the r cos theta get cancelled. Minus F sin theta by r cos theta. F by r is a mu. Then sin theta by cos theta is tan theta. Again I will say that here tan theta because sin theta by cos theta. Then plus mu. So F by r is mu divided by r cos theta by r cos theta 1. Then minus mu tan theta. So F by r is equal to mu. Then sin theta by cos theta is tan theta. That is equal to v squared by rg, where mu is equal to F by r. Then v squared is equal to, you bring this rg here. So mu plus tan theta by 1 minus mu tan theta. V is equal to root of rg, mu plus tan theta by 1 minus mu tan theta. When there is no friction between road and tires, if you take mu is equal to 0, then what will happen? Velocity is equal to root of rg tan theta. So v squared by rg is equal to tan theta. Then theta is equal to tan inverse of v squared by rg. So very simple, students. So here we have to square v square. RG tan theta. Then you bring the RG here, V squared by RG which is equal to tan theta. Then theta is equal to tan inverse of V squared by RG. This angle theta is called as the angle of bunking for minimum wear and tear. So if the angle is not in this angle, what will happen? The car will be upside down. It will be upside down while moving in the bunking of roads. So in the bunking of roads, very simple. So R is resolved into cos theta and sin theta. F is resolved into cos theta and sin theta. So R sin theta and F cos theta moving towards the center, and R cos theta and F sin theta will be acting towards the MG. So very simple, students. We are seeing that the circular motion of the car in level road and the circular motion of the car in bunked road. These questions are very important as that of the projectile motion in the last unit. So this circular motion in of the car in a bunked road and level road is important for annual NCERT point of view as well as the JE and NEET point of view. Understand the concept clearly, students. Thank you.